Have you ever wondered uh, what it truly means to leave Earth? Not just to go up, to fly in a plane, or to rise above the clouds, but to go beyond, well, to reach that invisible line where the sky ends and space begins, where our breath becomes impossible, our weight disappears, and the rules of life as we know them start to bend. And they bend in ways that feel almost unreal. What is it that draws us there? Is it curiosity? Is it survival? Or is it simply the call of the unknown, the, the quiet pull of something beyond our little world? Tonight, we're going to take a journey through 100 facts, small truths perhaps, but each one a stepping stone across the vast sea of space. And we've arranged them into 12 chapters. Think of them as portals, each opening to a different aspect of space travel, from the basics of orbits and rockets to the intimate details of life in microgravity, to the dreams of stepping onto other worlds. Some of these facts you may know, and you may feel a gentle sense of recognition. Others, perhaps, will surprise you. And that's the fun part. Maybe you'll count how many you already knew, or maybe you'll just listen and let your mind drift outward. It might feel as though your thoughts are slowly lifting off too. Before we go on, I'd like to ask you to subscribe to the channel and leave a like, but only if this space truly feels right for you. My aim here is simple, not just to help you learn, but also to help you drift off to sleep while exploring the wonders of science. It's not just about information, it's about ease, it's about rest. Where are you on the map? And, well, let me know where you are in the world and what time it is in the comments. It's always fascinating, it really is, to see who's joining us from all around the world. So let's continue. So what is space? Or more precisely, where does space actually begin? Well, you see, it's not so simple. We walk around every day under this vast blue sky, feeling the air brush against our skin. But up there, just above our heads at some point, the air thins and the sky goes from blue to black. And that's the thing, that invisible boundary is called the Kármán line. And, well, most scientists agree, space begins at about 100 kilometers above the surface of the Earth. It's not a wall, not a hard border. It's just a gradual fading, a thinning out, until suddenly there's almost nothing. So what does that mean? It means that space is not just up. It's not a place you simply climb to. No, to really be in space, you have to reach a place where the Earth can no longer hold you, where gravity's grip is, well, it's still strong, but you begin to float, not because gravity has vanished, but because you're falling, and missing the ground over and over again. That's what it means to orbit. That's what it means to travel in space. It's not just going higher, it's learning to fall forever, sideways, around a planet. And that brings up the next thing, the next piece of the puzzle. In space, there's no air to carry a sound. So if you were floating out there trying to call out, no one would hear you, not because you're not speaking, but because there's nothing at all for your voice to travel through. Sound needs a medium. Here on Earth, that medium is air, or water, or metal. Out there, your voice is swallowed by the silence. A silence so complete, it's almost cosmic. So, why is it so hard to leave the Earth? Why do we need rockets, massive and loud and burning with unbelievable energy? It's not just about height, you see. It's about speed. You need to go fast enough, so fast that you're not falling back. The speed you need to truly escape, to slip away from the pull of Earth. is about 11.2 kilometers per second. That's escape velocity. It's it's a speed so quick, so relentless, that if you could drive your car at that speed, you'd get from New York to Los Angeles in less than 5 minutes. Not just quick, but well, unthinkable. And yet, space, it's not empty. We say the vacuum of space, but that's not quite right. It's close, yes. So empty that a single atom drifts in a space the size of a small room. But there's still something tiny particles, dust, the faint breath of plasma, radiation, the subtle wind from the sun. You see, it's not absence. It's almost absence. And that makes it strange and a little unsettling, because we imagine space as a perfect void. But even in the deepest night, there is always something moving, something whispering, well. And in space, directions lose their meaning. There's no up or down in any universal sense. On Earth, we feel gravity's tug and know which way's which. But up there, any direction can be forward or backward or sideways. The universe doesn't care which way your feet are pointing. And, well, sometimes that's hard for us to accept. We're used to having a floor beneath us, a sky above. But in space, all that is gone. You float, and orientation becomes just relative. So time itself gets mixed up with space. In the universe, time and space are not separate. They're woven together. It's what Einstein called space-time. Not just a clock ticking away, not just a road stretching off into the distance, but a landscape, a fabric that we move through. You see, when you travel very fast or stand in a strong gravitational field, time itself bends and twists. The second is not always a second. Sometimes you age a little slower or a little faster, depending on where you are and how you move. So time becomes a part of the journey, not just a background to it. And space travel is never just science. It's never just engineering. It's always about the people, their courage, their bodies, their minds, because out there, every system is tested. The machines, yes, but also the humans, their endurance, their patience, their ability to cope with silence and distance, and the fragility of life in a place not meant for us. You see, space travel asks us not just what we can build, but who we are and what we're willing to endure. It's not simply about escaping Earth's pull. It's about meeting the universe on its own terms. To look out a window, one thick pane of glass between you and infinity, and realize that you're both very small and, at the same time, part of something impossibly large. So when we talk about space travel, we're really talking about the meeting point between dreams and physics, between imagination and reality. It's the story of reaching for something more, for something we can barely imagine, not just leaving Earth, not just moving outward, but moving forward. For all of us, and, well, if we're honest, there's something about counting, about listing these facts, that is in itself hopeful. Because every fact is a question answered a little step further into the unknown. And as you listen, maybe you'll wonder which of these facts you already knew. Maybe you'll think about where you were the first time you looked up at the night sky and wondered, what's out there? What's waiting just beyond the blue? We've talked about the boundary of space, the silence, the dance of orbits, and the strange, beautiful marriage of time and distance. But, of course, to really get out there, to truly cross the boundary, we need more than curiosity. We need the tools to get there. We need rockets machines, the wild, improbable idea that a human-built thing can push itself off the ground and soar all the way into the night. So, as we drift from these first facts, let's look a little closer. Let's ask, how do we actually get there? What powers the journey from home to the stars? That's where our story moves next. So to really get out there, to break the hold of Earth, we need more than dreams. We need machines, and not just any machines, but rockets, those towering, thunderous marvels of engineering. And when we talk about rockets, we're talking about something both brutally simple and impossibly complex, all at once. A rocket moves because, well, it throws things out the back. That's it. That's the fundamental principle, the law of conservation of momentum. You know, you want to go up, you push something else down, or out, or away. It's the same as jumping off a raft. You leap one way, and the raft scoots off the other. But a rocket is, well, a controlled explosion. You pack it full of fuel, and when you light that fuel, it burns, creating gas, incredible amounts of gas, and it pushes out fast through a nozzle, creating thrust. That thrust, that constant push, is what lifts us off the ground and just maybe into orbit. And it's amazing to think that most of the rocket, when you see it on the launch pad, isn't spacecraft at all. It's fuel. It's almost all fuel. The astronauts, the payload, the satellite, those are just the tiniest pieces riding on a tower of fire and hope. And, that's why rockets are so big. They have to carry enough fuel to push themselves and all their fuel all the way up, all the way out. You burn most of what you're carrying just getting through the thick lower atmosphere, just fighting gravity's grip, just getting started. So, rockets aren't built in one piece. They're made in stages, stacks of engines and tanks, one on top of the other. As each stage uses up its fuel, it's dropped away, left to fall back to Earth, making the rocket lighter and lighter as it goes. This staging, this letting go, is what makes reaching space even possible. It's not just about power, it's about letting go of what you don't need at exactly the right moment. And each piece that falls away is a little sacrifice, a reminder that nothing about this journey is waste-free. Now, think about those first moments after liftoff, the rumble, the vibration, the shaking so violent it rattles your bones. The rocket punches upward, pushing through the thickest air, the densest part of the sky. That's when it's hardest. That's when the machine groans under the strain, and every bolt, every weld is tested. For the astronauts inside, those few minutes are, some of the wildest of their lives. Everything shakes, everything howls, and the G-forces press them back into their seats. And launch sites, you'd think maybe you could launch a rocket from anywhere. But, most launch pads are built near the equator. Why? Because the Earth itself is spinning fastest there. That spin gives rockets a little extra push, a little boost from the planet's own momentum. And, when you're trying to escape a planet, every bit of help counts. Every drop of fuel saved is a chance to carry a heavier payload or reach a higher orbit. There's something almost poetic about that, don't you think? The planet helping us escape, just a little, just enough to let us go. And, of course, when those rockets light up, the sound is unimaginable. Not just loud, but a kind of thunder you feel in your chest. Unchecked, that sound could shatter buildings, break windows, ripple out for miles. Engineers have to design giant water systems, sound suppressors, just to keep the launch site from being shaken apart by the rocket's own voice. And it's not enough for a rocket to go straight. No, to reach orbit, to become a satellite, you need to start tilting sideways, bending your path, so that you're not just climbing, but, well, you're starting to fall around the Earth. The gravity turn, as it's called, is this gentle, controlled tip, a dance between up and sideways, between ascent and orbit. So, and as each stage finishes its work, it drops away. Some pieces fall back to the ocean. Some, well, burn up in the sky, tracing brief fire across the edge of space. A few these days are caught, reused, brought back to fly again. That's new, this idea of a rocket you can use more than once, like a plane. It's changing everything. This idea that maybe space doesn't have to be wasteful. Maybe we can learn to come and go, not just visit once, but return. But still, for most launches, the rocket's spent stages are left to gravity. They tumble, unseen, back to Earth, sometimes recovered, sometimes lost to the waves. It's the price we pay to reach the stars, a trail of empty shells falling away behind us, each one a mark of the struggle, the cost, the hope. And, well, think for a moment about the roar, the fire, the sheer violence of launch. The rocket is not just fighting gravity, it's fighting the very air itself. The thick, turbulent atmosphere is both friend and foe. In those first moments, the forces pressing against the rocket's skin are greater than at any other time in flight. That's why so much engineering goes into making sure the rocket doesn't break apart, doesn't shake itself to pieces before it ever sees space. There's a strange kind of beauty in that, isn't there? This delicate balance between destruction and escape. And as the rocket breaks through the last wisps of cloud, as the sky darkens from blue to black, as the engines fall silent and the last stage falls away, only then does the craft truly float free. Only then has the boundary been crossed, the world left behind. But getting there, well, that's the work of giants, of fire, of fuel burned in moments that took years to plan. And to see a launch, to feel that sound, to watch the flame blossom and vanish into the sky, is to understand, in some way, just how hard it is to leave home. Not just hard, but costly. Not just costly, but worth it for what waits above. So, and there's something else. When we watch a rocket climb, we see power. But what we don't see is the careful math, the gentle steering, the way a rocket must lean, twist, and turn, not just for height, but for speed, for the perfect angle to find orbit. If you launch straight up, you fall right back down. The trick is in the turn the arc, the subtle bend that lets you miss the ground forever. And this means that every launch, every rocket is an act of faith and an act of precision. So much can go wrong, and so often it has. Yet, we keep trying, we keep building, because out there, in the darkness, is possibility. There is, well, a certain poetry in letting go. Every stage released, every ton of metal discarded, is a step closer to freedom. And the path to space is littered with these cast-off shells, remnants of hope, of human hands reaching just a little further. And today, more and more, we see rockets designed to return to land again, to be used another day. This idea, this vision of reusable rockets is shaping a new era, one where space might become not just a place to visit, but a highway, a frontier open to all. So you might wonder what comes next. We have the machines, the power, the stages, and the plans. We have learned how to leave the ground behind. But what happens once we are free of Earth? Once we are truly flying in the black? How do we stay up there? How do we move? How do we dance between the planets and the stars? That, well, that is the next question. That is the next story. The story of orbits, of gravity, of flight without wings. Let's drift a little further and see where the path leads. So we've watched the rocket burn, the stages fall away, and the final engine shut down as our spacecraft floats. Free, at last, above the world. And what happens now, you might wonder? What does it mean to fly in space when there's, well, almost nothing left to push against and nowhere to stand? It's not what most people imagine. There are no wings, no up or down, only the quiet, endless curve, the invisible path that we call an orbit. You see, to orbit the Earth is not to hover, not to sit motionless above the ground. It's to fall and to keep missing. That's the truth. The spacecraft, the satellite, the station, they are falling, always falling, but they're moving forward so fast, so relentlessly, that the Earth curves away beneath them. They fall, but the ground keeps escaping, so they never quite reach it. That's the secret of an orbit. It's not about defeating gravity. It's about learning to dance with it, to ride its pull, never breaking free, but never surrendering either. Let's take the low Earth orbit, for instance, LEO, as it's often called. Well, this is the realm of the International Space Station, the Hubble telescope, and countless satellites. LEO sits usually between 160 and 2,000 kilometers above the ground. Up here, the sky is black, the air is almost gone, and the Earth below looks impossibly curved. And yet, it's still close enough that gravity's pull is strong, just a little weaker than at the surface. So to stay up here, you need to move fast, really fast. Around 28,000 kilometers per hour. That's nearly 8 kilometers every second. And this is what people often misunderstand. To stay in orbit, to not come crashing back down, you don't need to be far, you need to be fast. It's not distance that holds you up, it's speed. Like spinning a ball on a string. The faster you go, the tighter the circle, the more tension in the line. If you slow down, you fall. If you go faster, you fly away. Well, not all orbits are created equal. Some are close, some are far, some are so high they hover almost motionless in the sky. Geostationary orbit now, that's a magical place, more than 35,000 kilometers out. A satellite here circles the Earth once every 24 hours, matching the planet's spin. So from the ground, it seems to hang in the same spot, always above the same patch of Earth. This is where our television satellites live, and the ones that send signals to weather stations, to distant ships. They become a kind of anchor in the sky, a point of certainty in an ocean of motion. But to get there, well, to reach that altitude, you need not just energy, but careful planning. You see, changing orbits in space, going higher or lower, moving from one path to another is not easy. It costs fuel. And in space, fuel is everything. Every kilogram, every litre must be carried with you, every drop counted, every manoeuvre weighed against the precious resources you have left. So every mission is a puzzle, a game of balance. How high, how fast, how much can you spare, and when do you change course? That's what keeps the mission planners up at night. Every burn of the engine, every tiny adjustment has to be perfect. There's no air up here to slow you down. no wind to turn your sails. Only the cold math of physics, the silent tug of gravity, the endless patience of time. And sometimes we use gravity itself as an ally. This is the slingshot, the gravitational assist. A spacecraft approaches a planet, swings close, and steals a bit of the planet's speed, flinging itself onward with new energy. It's like grabbing onto a merry-go-round and letting go at just the right moment to fly even faster. This trick lets us reach distant worlds, cross immense gaps, using the planets as stepping stones, as cosmic partners in the dance. And, well, it's strange to think that in space, most of your energy, most of your effort is not used to go higher, but just to reach orbit at all. Getting up is hard, but staying up is the real challenge. And once you're there, well, you have to stay vigilant. Tiny changes in speed, small nudges at the right time, can make a world of difference later. A slight burn here, a course correction there, and you might end up halfway across the solar system or crash back down if you're not careful. Some orbits are perfectly circular. Others are long ellipses stretched, drawn out, bringing a spacecraft close to Earth at one moment and flinging it far away the next. This can be useful or dangerous. An elliptical orbit might, say, let a probe skim low over a planet, then soar high into space to send back its discoveries. Or it might make it harder to stay safe, to predict where and when the spacecraft will pass over a certain point. You see, orbits are not just lines on a map. They are, well, living things, changing, responding to every force, every bit of dust, every whisper of solar wind. The spacecraft is never truly alone. It's part of a vast, shifting system, a ballet of objects and energy, light and darkness. And all of this matters because in space, you can't just pull over and stop. There's no parking brake, no ground to rest on. Every move must be planned, every path mapped, every contingency considered. To change course, you need to burn fuel. To go faster, burn fuel. To slow down, burn fuel. And you only have so much. But sometimes it's the smallest adjustment that makes the greatest difference. A change of speed by just a few meters per second, done at the right moment, can send a spacecraft to another world, or keep a satellite circling safely above our heads. Timing is everything. In space, time, and velocity are partners. The when matters as much as the how. And, well, if you look up and see a satellite gliding across the night sky, you're witnessing this delicate dance. It's not just moving forward, it's falling forever, tracing a path that was calculated months or even years before. Every satellite, every probe is the result of this complex choreography. Every orbit is a promise, a balance between speed and gravity, between hope and mathematics. And as we talk about orbits, maybe you notice something else. There are orbits within orbits, layers upon layers. The low Earth orbits, close and fast, where the International Space Station circles, so close that the astronauts see 16 sunrises and sunsets every day. Farther out, the medium Earth orbits, home to navigation satellites, guiding our journeys on Earth, silent partners in our everyday lives. And farther still, the geostationary belt, a thin ring around the equator, holding its fixed sentinels. But there are orbits that go farther, higher, more elliptical, Molniya orbits, for example, that spend most of their time far from Earth, then swoop low for a quick pass. Useful for covering high latitudes, places regular orbits can't reach. And then, well, There are transfer orbits, paths that carry spacecraft from one world to another using the least energy, the most elegant geometry. And uh, sometimes we use orbits in ways that seem almost magical. The slingshot, as I mentioned, isn't just for speed, it's for saving fuel, for turning impossible journeys into possible ones. We've sent probes to the outer planets, to comets, even out of the solar system entirely, by flinging them around planets like stones in a cosmic game. Yet, and, well, in all this elegance, there's fragility. Orbits can decay. Even in the high vacuum, there's still a whisper of atmosphere, still a drag, slow but relentless. Satellites in low Earth orbit eventually spiral down, burning up in the atmosphere, ending their journeys in a brief flash. Higher up, things last longer, but nothing is forever. Space is a place of motion, of change, of impermanence. And sometimes orbits cross, intersect, overlap. The sky above our heads is crowded now, thousands of satellites, pieces of debris, each tracing its path, each a potential hazard for the others. We track them, catalogue them, predict their movements, because a collision at orbital speeds is catastrophic. A fleck of paint, a screw, a lost bolt, moving fast enough to shatter metal, to end missions. Space is big, yes, but our orbits are crowded, and the risks are real. So, well, let's pause for a second. Let's think about what this all means, not just for spacecraft, but for us, for our lives. Every phone call, every GPS coordinate, every weather map, these are gifts from orbit, from machines circling high above, tracing lines in the invisible air. And sometimes the challenge is not to stay in orbit, but to leave it, to return to Earth. You have to slow down. That means turning your spacecraft, firing your engines against your motion, letting gravity take over. If you don't slow down, you stay forever. If you slow too much, you fall too fast, burn up in the fire of re-entry. There's a balance, a tightrope to walk between speed and safety, between home and the void. But in all these journeys, in every orbit, there is purpose. There's a reason for every satellite, every probe, every mission. Some bring us knowledge, some keep us safe, some connect us, weaving a web of signals and data that wraps around the planet. It's easy to forget how much of our world depends on this invisible infrastructure, this ballet above the sky. And sometimes we send people, astronauts, cosmonauts, taikonauts, names for those who ride the fire, who float in weightlessness, who see the world from above. For them, orbit is both home and exile, a place of beauty and sometimes loneliness. The earth below, always moving, always out of reach. Sunrises and sunsets in quick succession, continents slipping beneath, weather systems swirling, the thin blue line of atmosphere a fragile shield. It's not just technology up here, it's humanity too. The hopes, the fears, the longing for connection. From the first satellites to the vast constellations we launch today, every orbit is a testament to our desire to reach out, to see more, to know more. And, well, maybe you're starting to feel it now. That space, that emptiness, isn't empty at all. It's a place of motion, of energy, of life. The orbits are our highways, our neighborhoods, our signposts in the cosmic dark. And as we look ahead, as we plan new missions, we're always thinking, how can we go farther, stay longer, use less, risk less, see more? Each orbit is a lesson, a challenge, a question answered, and 100 more asked. So, What happens to the people who live in this environment? What does it mean for the human body, the mind, the spirit, to live in microgravity, to call orbit home for weeks, months, sometimes even years? That, well, that's the next part of our journey, a place where physics meets biology, where dreams meet the hard realities of flesh and bone. Let's drift there together and see what it really means to live, to survive, and perhaps to thrive, floating high above the world we once called home. So let's drift together into this next chapter. A chapter not just of machines and physics, but of bodies and minds and the strange, gentle brutality of life in orbit. When we speak about living in space, we're talking about something almost paradoxical. It's not just the thrill of weightlessness or the freedom of floating through a station. It's the story of adaptation, of a body built for Earth, for gravity, for standing, walking, running, suddenly set adrift in a world where none of those rules apply. And, well, it's not just about the body, but also about the mind, the soul, the sense of self. So let's start here. In orbit, you're never truly weightless. You're in what scientists call microgravity, and that's an important distinction. It's not the absence of gravity, but a constant state of free fall. The station, the ship, the astronaut, everyone and everything is falling together, tracing that endless curve around the planet. There's still gravity, it's just that you and the ship are falling at the same rate. And so inside, it feels as though weight has vanished, but it hasn't. It's just hiding, just for a while. And the human body, it notices the difference immediately. The bones, those long pillars in your legs and spine, they evolved to resist gravity's pull. They grow strong because they have to fight every second of every day against the weight of your own body. In microgravity, that fight is gone. The bones start to change. They lose density. They grow weaker, more fragile, as if forgetting what they were made for. Astronauts can lose a measurable percentage of bone mass after just a few months in space, sometimes as much as 1 to 2% per month. It's a kind of slow, silent erosion. And it doesn't stop there. Muscles, too, are shaped by the load they carry. The calves, the thighs, the back, all those fibers that help us stand upright begin to shrink, to soften when they're no longer needed. We lose what we don't use. And in orbit, it's easy to float, to drift, to never strain. So astronauts must exercise for hours every day, pushing against machines built to create resistance in a place where gravity is barely felt. Treadmills, resistance bands, special machines, these become lifelines, holding on to strength, holding on to health. And the face, even the face changes. Fluids, no longer pulled down by gravity, shift upward. The cheeks swell, the eyes puff out. Astronauts often look, well, almost cartoonish in those first few days. The pressure in the head increases, sometimes leading to headaches or changes in vision. Some astronauts return to Earth with altered eyesight, a reminder that even the eyes are shaped by the forces we take for granted. Sleeping, too, is different. On Earth, we lie down, pulled gently by gravity, cradled by the familiar embrace of the bed. In space, you must strap yourself in or zip yourself into a sleeping bag tethered to the wall or ceiling or, well, to what used to be a ceiling. You float, cocooned, sometimes drifting gently in the air, sometimes feeling utterly unmoored. There's no up or down. The sense of direction fades, and the rhythms of night and day are erased by the station's relentless motion, 16 sunrises and sunsets every 24 hours. The body's clock, the mind's sense of time begins to slip, to blur. And, um, well, personal care becomes an act of ingenuity. Water doesn't flow, it beads up, floats away, clings to surfaces. To wash, you dab at your skin with a wet cloth, careful not to let droplets escape. Hair floats in all directions. Tears, sweat, even breath, everything behaves differently. Using the toilet is a triumph of engineering, a dance with airflow and vacuum pumps. Waste must be carefully contained, recycled, or stored until it can be returned to Earth or burned up in the atmosphere. Eating now, that's a ritual of adaptation. Food comes in packets, pouches, tubes, carefully engineered to avoid crumbs and spills. You open a pouch, squeeze out a bite, and catch it with your mouth. Crumbs can be dangerous, floating into electronics, clogging filters. Drinks must be sucked from straws. And every meal is a reminder of home, of what is missing, of what is precious. The taste of real bread, of fresh fruit, of a hot cup of coffee becomes a distant memory, a longing. But perhaps the strangest change is inside, in the balance system, the inner ear, the vestibular sense. On Earth, this system tells us which way is up, how to stand, how to move. In orbit, it loses its reference, and confusion sets in. Some astronauts feel sick, dizzy, disoriented, a kind of space motion sickness that can last days. The body, the brain, must learn and relearn to trust new signals, to find new balance. It's not just about surviving, but about adapting. Every astronaut carries with them not just their body, but their habits, their routines, their ways of coping. In microgravity, everything must be reinvented, reimagined. The simplest acts, eating, sleeping, working, even laughing, take on new shapes, new meanings. But let's not forget the emotional world. The mind, too, is changed by life in orbit. Isolation, confinement, the ever-present sense of risk, these weigh heavily. The view outside is magnificent, but also distant. Friends, family, the ordinary sounds and smells of Earth all are gone. Communication is a lifeline, a thread connecting astronauts to the world below. But even with calls, with emails, with video links, there is loneliness, a deep, private solitude shared only with crewmates. And the bonds that form among astronauts are forged in this crucible. There's a sense of interdependence, of shared purpose. You must trust, must rely on, must forgive. A single mistake can have consequences for everyone. So the social rituals, shared meals, laughter, stories, quiet moments become anchors, reminders of humanity in the silence of space. Yet, in all this, there's wonder, too. To float, to somersault through a corridor, to gaze out the window and see the curve of the earth, the thin blue shield of atmosphere, the endless night beyond it. Well, it's a dream, a privilege, a kind of gentle miracle. The body is challenged, the mind is tested, but the soul is lifted. But let's look at a few details. Every day, astronauts follow strict routines. Exercise is not optional, it's survival. Blood without gravity pools in the upper body. The heart, no longer needing to work as hard, can become weaker. So the treadmill, the cycling machine, the resistance devices, they're all carefully calibrated, measured, tracked. Doctors on Earth monitor health, send advice, adjust routines. Every gram of muscle, every bit of bone density is guarded. And every piece of waste, every drop of water is recycled. The air is filtered. The moisture from breath and sweat is captured and turned back into drinking water. Even urine is processed, purified, made clean again. In space, nothing can be wasted. Every resource is precious, every system a testament to ingenuity. There's creativity, too. Astronauts bring little reminders of home photos, trinkets, sometimes a favourite song or a book. Holidays are marks, birthdays celebrated, traditions kept alive in small ways. It's these touches of humanity, these rituals, that make life in orbit more than just survival. And research goes on. The microgravity environment is a laboratory, a place where cells grow differently, where flames burn in spheres, where new materials can be tested, where medicines can be developed. Every day, astronauts become both subject and scientist, their bodies teaching us what it means to live away from home. But it's not always easy. Some come home changed, bones thinner, muscles weaker, hearts slower. Some need months to fully recover. Some never quite do. The body remembers space, the mind too. Yet most say they would go back if given the chance. So what does it all mean? It means that space, for all its beauty, is not friendly. It's not a place made for us. We must adapt, must reinvent ourselves, must learn new ways of being. And in doing so, we learn not just about survival, but about ourselves, our resilience, our fragility, our longing for connection. And, well, as we look ahead, as we imagine longer journeys, years instead of months, perhaps lifetimes instead of years, we must ask, how will we change? What will humanity become when the world below is just a distant memory and the only home is the one we build together among the stars? So let's look beyond the body now. Let's step outside just for a moment into the machines themselves, the spacecraft, the stations, the homes we build above the sky. Because in the end, to live in space is not just to float, but to create new places, new worlds, in which our old dreams can still take root. And that is where our journey leads next. So as we move further on this journey, let's imagine what it means to build a home where there is no ground, no weather, no horizon, nothing but the endless, circling dark. Because, well, for all our dreaming and science, for all our rockets and orbits, at some point we must create a place to live. And that's where the space station enters the story, not just a ship, not just a laboratory, but a house in the sky. The International Space Station, the ISS, is perhaps humanity's greatest experiment in living off the world. And it's not just the ISS, other stations came before, others will come after, but for now, it's the one we look to, the one that orbits above us, always moving, always just out of reach. The ISS circles the Earth, not once, but about 15 or 16 times every single day. That means, well, every hour and a half, it completes a full lap, racing at a speed that defies everyday intuition, more than 27,000 kilometers per hour. So the astronauts inside are never still. They see the world pass beneath them at breathtaking speed, continents sliding by, clouds blossoming and dissolving, cities glowing and then fading into darkness. And with each lap, the crew experiences a new sunrise, a new sunset, 15 or 16 of each, every single day. The world outside is always changing, always in motion. We grow older, clocks tick, but on the ISS, time moves in loops, in cycles, in orbits. And this place isn't as far away as you might imagine. The station orbits at about 400 kilometers above the ground. That's, well, only about the distance from, say, New York City to Washington, D.C. It's high enough that the atmosphere is thin, that drag is low, but it's close enough for supply ships to reach it, for rescue, for return. So, so there's a delicate balance close to home, yet impossibly far, a step beyond the world, but not quite lost to it. But the ISS is not one thing, not a single structure built in a single moment. It's a patchwork, a mosaic. Each module, each segment was launched separately, carried into orbit by rockets from different nations, assembled piece by hands, both robotic and human. Over years, and, well, even decades, it grew expanding, linking, connecting. It's not just a station, it's a symbol, a living proof that collaboration is possible, that we can work together even when the stakes are cosmic. Inside, the air is precious, and every breath is recycled. The oxygen you inhale today might have been breathed out by your crewmate yesterday, or even by yourself just a few hours before. Machines scrub carbon dioxide, harvest water from the air, squeeze every molecule of life from every available source. Nothing is wasted, not air, not water, not even sweat or breath. The moisture in your breath, the vapor from your skin, all of it is captured, condensed, filtered, turned back into water, into life. Some water even comes from, well, the recycling of urine, a fact that may seem unsettling at first. But up there, every drop is precious, every system is a small miracle. And food is a ritual and a challenge. Everything must be light, compact, shelf-stable, and safe for zero gravity. Meals are eaten together in a small galley, floating side by side, sharing stories, sharing jokes, sharing, well, the strange intimacy of shared survival. There's no refrigerator, no oven, but the kitchen is alive, with laughter, with care, with the sense that here, in the smallest of rituals, is a piece of home. The ISS is not just a house, it's a laboratory, a place of science, of discovery. Experiments happen everywhere, in racks, in modules, even in the sleeping quarters. Plants grow differently here, cells divide in new patterns, fire burns in spheres, metals cool into shapes never seen on Earth. The station is a window into the unknown, a test of what's possible, a laboratory for a future not yet written. Every crew member is both caretaker and scientist, part of the experiment, subject and observer, learning not just about space, but about the world, about ourselves. And, well, the atmosphere inside must be controlled, balanced, protected. Every bit of air, every breath must be accounted for. Machines hum quietly, working day and night to maintain pressure, to keep the balance of oxygen and nitrogen just right. Filters catch dust, bacteria, even stray hair. The air is tested, sampled, cleaned, again and again. It's not just technology, it's vigilance, it's care. It's a reminder that up here, life is fragile, and the line between safety and danger is thinner than a window pane. The modules themselves are varied, some for science, some for living, some for exercise, some for docking new ships. Each module was built with a purpose, designed to fit with others like a great cosmic puzzle. Some came from Russia, some from the United States, some from Europe, from Japan, from Canada. The station is a map of human ingenuity, a testament to what can be achieved when borders fade, when, well, the only boundary is the sky. And there's always motion, always change. Cargo ships come and go, bringing food, water, parts, new experiments. Crews rotate in and out, some stay for months, a few for nearly a year. The station itself is kept alive by constant attention, by repairs, by upgrades, by the hands of those who call it home. Each mission, each launch, each spacewalk adds to the legacy, to the story of this strange, beautiful house in orbit. And life inside is not always easy. The noise, the constant hum of machines, the lack of privacy, the closeness of crewmates, it can be overwhelming. There's no true night, no true day, just the steady glow of artificial lights, the relentless cycle of work, exercise, science, and sleep. Every moment is structured, every hour counted. Yet, somehow, in this tight schedule, there is room for laughter, for music, for birthdays, for holidays, for moments of reflection. It's not just a laboratory, not just a machine, it's a home in all the ways that matter. And the view, well, the view is beyond words. To look out a window, to see the earth, curved and blue, spinning beneath you, that's something no photograph can truly capture. The continents, the oceans, the storms, the lights of cities at night, these become both familiar and alien, both home and somehow art. Astronauts speak of the overview effect, the sense that when you see the world from space, you understand in a new and deep way just how connected, just how fragile, just how precious it all is. But, and there's something more, the ISS is not just an outpost, it's a step, a stepping stone. Every piece, every module, every experiment is a rehearsal for what comes next. Longer journeys, deeper exploration, more permanent homes beyond Earth. We test technologies here, air recycling, water reclamation, food systems, medicine, psychology. We test the very limits of what it means to be human in a place so far from the world that made us. And, well, as you walk well, as you float through the corridors of the station, you are surrounded by reminders of Earth, by flags, by photos, by tiny treasures brought from home. Every crew member leaves a mark, sometimes a drawing, sometimes a patch, sometimes just a memory, a story passed on to the next visitor. The ISS is a story not just of science, not just of survival, but of community. It's proof that we can build something beautiful, something lasting, if we work together. It's a promise to the future, a reminder that for all our divisions, we are, in the end, one species, sharing one tiny blue planet, spinning in the dark. And maybe as you listen, you start to wonder, what's next? Where do we go from here? What happens when we leave the safe haven of the station, when we reach for the next world, the next challenge? Because, well, the story of space stations is not just about staying, it's about going. It's about reaching farther, about dreaming bigger. So, as we drift away from the familiar comfort of the ISS, let's cast our minds forward to the moon, to Mars, to the places where footprints linger in dust and dreams are written in silence. Let's see what it means to leave home entirely, to risk everything, to take the next step out into the cosmos. So, after all the routines and rituals of life in orbit, after learning how to build a house in the sky, we come to a threshold, a line that, for most of human history, seemed impossible to cross. The story of space travel is, well, the story of boundaries, the boundary of the atmosphere, the boundary of gravity, the boundaries in our imagination. But perhaps the most iconic boundary we've ever crossed is the distance between the Earth and the Moon, and the Moon is, in a way, both close and unimaginably far. It's the first, and so far, the only world beyond Earth where humans have left their footprints. That moment, the first step onto lunar soil, was not just a leap across space, but, well, a leap for our sense of what's possible. We, humans, looked up at the brightest thing in the night sky for thousands and thousands of years, And then, suddenly, we touched it. Um, the journey to the moon is not a short hop. It takes about 3 days to travel the almost 400,000 kilometers from the Earth to the moon. And yet, in the vast scale of the cosmos, that's just next door. It's not uh, a trip you make in a straight line either. The spacecraft follows a curved path, an arc through space, carefully calculated to match the moon's orbit and gravity. Everything is a balance, a dance between falling and missing, between the push of rockets and the pull of the moon. And to get there, we needed a machine like nothing the world had seen before. The Saturn V rocket, still one of the most powerful rockets ever built. It was as tall as a 30-story building, a column of metal and fuel designed for one purpose, to send people farther from home than anyone had ever gone. When it launched, the ground shook, windows rattled miles away, and, well, you could feel history changing in the vibration of the air. That rocket carried the Apollo missions, the brave handful of astronauts who made the journey, who risked everything for a glimpse of another world. Their ship became, in those days, the most isolated place in human experience. Imagine, for a moment, floating in a tin can, so far from Earth that even a radio signal takes more than a second to cross the gulf. Imagine looking out the window and seeing your home as a marble, blue and white, suspended in endless black. The moon itself is a strange and haunting place. Its gravity is only about 1/6 that of Earth, so every movement is changed, each step becomes a bounce, each jump an arc of slow, dreamlike flight. The dust is everywhere, fine as powder, sharp as glass. It sticks to suits, clogs, machinery, and, well, can even pose a risk to lungs if inhaled. The surface, marked by craters and boulders, is silent. No wind, no rain, no sound but what you make inside your helmet. It's a landscape as old as time, almost unchanged for billions of years. And the samples that came back, the rocks and soil, the tiny relics of another world, taught us not just about the moon, but about the Earth itself. Hidden in those fragments are clues to our own past, to the story of the solar system, to the ancient violence and slow settling that shaped our home. Not just that, not just knowledge, but perspective. To stand on the moon, to look back and see the Earth rise above the horizon, so small, so delicate, so achingly far, is to understand how precious, how fragile, how singular our planet is. Astronauts speak of the overview effect, a shift in consciousness, a sense that we are all connected, all sharing one world. The Apollo missions were brief. Each landing lasted only a few days. The journeys were dangerous, uncertain, and every moment was shadowed by risk. The lunar module was thin as a soda can, its walls just a few centimeters thick. Each mission left behind footprints, flags, and scientific instruments. And yet, each return, each splashdown in the ocean felt like a small miracle, a victory not just of technology, but of hope, of will, of human spirit. And, there's a question of the moon's far side. People call it the dark side, but that's not quite right. It's not always in darkness. It's just the side that always faces away from us, locked in a cosmic embrace. Standing there, you'd never see the Earth rise or set, just an unbroken black sky, with the sun rising and setting in a slow, alien rhythm. New missions now look to return, not just to visit, but to stay. Plans are being drawn, technologies tested, dreams expanded. The vision now is to build something permanent, a base, a home on the lunar surface. somewhere astronauts could live for weeks, months, maybe even years. The moon, once a destination, becomes a stepping stone, a place to learn, to test, to prepare for journeys still farther from home. And the lessons from the moon are not just technical, they're human. Each crew was a team, relying on trust, training, quick thinking. Mistakes were made, sometimes small, sometimes nearly fatal. But every return, every safe landing, every handshake on the deck of a recovery ship was a reminder we can do impossible things if we work together. The dust, the craters, the silence, these are part of the story. But so too are the laughter, the awe, the quiet moments staring out the window at a place no one had ever seen before. So too are the rocks brought home and the dreams carried forward. And as we look up, as we watch the moon move across the sky, we know that it's not the end of the road. It's the beginning of something larger. We talk now of Mars, of asteroids, of journeys measured not in days, but in months and years. So, well, as the dust of the moon settles, as the echoes of rocket fire fade, our attention turns outward again. The next horizon is red, cold, mysterious. The next chapter is about new worlds, about Mars, and about the other planets waiting in the dark. Let's take the next step and see what it really means to reach out, to travel farther than ever before. So as we watch the moon fade into the background of our imagination, we find ourselves standing at the edge of a much greater unknown. The next horizon is Mars, the red planet, and beyond that, well, the beckoning mystery of the outer worlds, places that, until recently, belong more to myth and dream than to science. And that's the thing. To talk about Mars, to talk about other planets, is to talk about the expansion of possibility. It's not just about new places out there, but about new stories, new hopes, new risks. Let's begin with Mars. Mars is a world both familiar and strange. A day there, a sol is just a little longer than a day on Earth. 24 hours, 37 minutes. So clocks tick just a little slower. We can imagine living by that rhythm, sleeping and waking, watching the sky change colour from butterscotch to blue at sunset and to pink in the dawn. But, well, that's where the similarities fade. Mars is cold, so cold. The surface, even at noon, rarely climbs above freezing. And at night, it can drop to minus 100 degrees Celsius. The ground is hard, covered in dust, carved by winds that have raged for billions of years. Sometimes those winds rise up into dust storms so vast they can blanket the entire planet, hiding everything beneath a red haze for weeks or months. The landscape is dotted with canyons, craters, extinct volcanoes that tower higher than anything on Earth. Olympus Mons, the largest volcano in the solar system, rises almost 3 times higher than Mount Everest. Imagine standing at its base, looking up and realizing that you're not just on another world, but at the foot of a mountain that defies the limits of imagination. Mars is a place of puzzles. There are channels, valleys, signs that water once flowed. There are frozen caps at the poles, made of ice and dry ice, shrinking and growing with the seasons. For decades, we've wondered, was there ever life here? Is there still, hidden deep below the surface, in salty pockets or frozen caves? Each new rover, each new probe, carries instruments to search for answers, looking for the faintest trace, the tiniest fossil, a chemical signature written in ancient dust. And our machines are the first explorers. The rovers, small, slow but resilient, crawl across the rocks, drilling, sampling, photographing. They send their data back to Earth, each signal taking between 4 and 20 minutes to cross the distance, depending on where the planets are in their endless dance. That delay well. It means every command, every adjustment is a leap of faith. The teams who drive the rovers must wait, must watch, must plan every movement hours in advance. Sometimes a wheel gets stuck. Sometimes a dust storm blocks the sun, starving the rover's batteries. And yet, the stories these machines tell are astonishing stories of ancient rivers, of salty lakes, of a world that once might have been more like our own. Landing on Mars is no small feat. The air is there, but only just so thin that parachutes barely work, too thick to ignore. It's, well, a world in between, an atmosphere that confounds our engineering. Every landing is a ballet of heat shields, parachutes, rockets, airbags, luck. Not every attempt succeeds. Many end in silence, and each success is a triumph, a sign that persistence matters. The gravity on Mars is about 38% that of Earth. So everything is lighter, but not weightless. A person there would walk in, long, slow hops, the way the Apollo astronauts did on the moon, but stretched out a little slower, a little easier on the bones and muscles. The lower gravity would change everything, how we move, how we build, even how our hearts beat. And to live there, to survive, we'd have to build habitats, shield ourselves from radiation, recycle every drop of water, every molecule of air. There's no ozone, no magnetosphere to protect from the sun's fury. To walk outside would mean donning a suit, bringing your world with you, step by cautious step. And we'd have to grow food in domes, using sunlight filtered through dust, or perhaps artificial lamps. Every resource, every drop, every seed, every breath would be precious. But Mars is not alone. The outer worlds await, their mysteries, just as deep. Jupiter and Saturn, the gas giants, are worlds without surfaces, vast storms swirling for centuries, colours and clouds and lightning beyond comprehension. To stand on Jupiter or Saturn is impossible. There's nowhere solid to stand, only air growing thicker and hotter until, well, it crushes, it burns, it becomes a place where matter itself is changed by the pressure. Yet their moons Io, Europa, Ganymede, Titan, those are worlds with stories of their own. Europa, for instance, is a tiny world of ice orbiting Jupiter with a smooth, cracked shell that may hide an ocean beneath an ocean larger than all the seas on Earth. And beneath that ice, warmed by the tides of gravity, could there be life? Not just the life we know, but something new, something unimagined, something that whispers in the dark beneath the frozen shell. And Titan, Saturn's largest moon, well, Titan has lakes and rivers, but not of water. They're made of methane, of liquid natural gas, flowing under an orange sky. The air is thick, cold, filled with organic molecules. Titan is, in some ways, more Earth-like than Mars, but twisted, transformed by cold and chemistry. Rains fall, rivers carve, valleys, and every drop is a puzzle, every landscape a riddle. So as we send our probes, our orbiters, our landers, we learn not just about these worlds, but about possibility. We find out what it means to search for life, to redefine what habitable means, to push the boundary between science and wonder. Every mission is a rehearsal for what might come, a time when humans, not just robots, step onto these distant shores. But it's not easy. Communication is slow, supply lines are long, risk is everywhere. The energy needed to reach even Mars is immense. To go to Jupiter or Saturn, to their moons, is an order of magnitude harder. The cold is deadly, the radiation intense, the time frames long. Even now, in 2025, these places feel like distant dreams. But, and dreams change. What seems impossible one decade becomes inevitable the next. And as for the other planets, Venus, shrouded in clouds and acid rain, a world of heat and crushing pressure, Mercury, blasted by the sun, day and night divided by fire and frost, Uranus and Neptune, pale blue and green, giant worlds of ice and storms we send our ships, our eyes, our curiosity, knowing that to visit in person may be, for now, beyond our reach. But even sending machines, even touching these worlds with our sensors, our cameras, our mathematics, brings them into our story. We grow older, clocks tick, but the worlds keep turning. Every planet, every moon is a new beginning, a new question. It's not just about the place, but about the act of reaching, of wondering, of not being satisfied with what we already know. We send probes not just to gather data, but to remind ourselves that there's always more to learn. So as we imagine the journeys ahead, the first human footprints on Mars, the first base beneath an alien sun, the first green shoot grown in red soil, we're also reminded of the risks. New places bring new dangers, new problems to solve. But that's the price of exploration, the cost of curiosity, and it's a cost we seem willing to pay again and again. And as we turn our gaze outward to the cold, the darkness, the distant dots of light, we know somewhere inside that we are not just explorers of space, but of time, of possibility, of what it means to be human in a universe of endless surprise. But, well, the story doesn't end with arrival. Every journey has its shadows, risks, dangers, things that can go wrong. In the next chapter, we'll face these realities, the dark side of space travel, the dangers that lurk in silence, in radiation, in isolation. Because, the farther we go, the more we must learn to survive, not just to travel. Let's turn now and look bravely into the shadows and see what waits in the darkness between worlds. So as we let our imagination wander further from the familiar warmth of Earth, and as we, chase the promise of new worlds, we can't ignore the shadows that stretch across the path. Space is, in its beauty, also an arena of danger, a place that tests not just our machines, but our courage, our ingenuity, and our resilience. Every journey into space, every orbit, every landing is a negotiation with risk. It's not just the dream of reaching the stars, but the reality of surviving in a universe that, wasn't made for us. Let's start with radiation. The sun, is not just a source of light and warmth, it's also a relentless emitter of high energy particles. On Earth, we are shielded by our magnetic field, wrapped in a cocoon that deflects most cosmic threats. In space, that shield fades. Astronauts are exposed to cosmic rays, solar flares, and bursts of energy that can pass straight through metal, straight through skin. The long-term risk of cancer rises, the body's cells are damaged, DNA is broken, and sometimes never perfectly repaired. Every mission planner, every crew must watch the space weather, must prepare for storms that arrive with only minutes' warning, must design every suit, every wall, with this invisible hazard in mind. And then there's the problem of space debris, tiny fragments left from old missions, dead satellites, exploded rocket stages. Some are as small as a grain of sand, others as large as a car. But all of them, every piece, moves at tremendous speed, 10, 15, even 20 kilometers per second. A marble at that speed could puncture steel, destroy a spacecraft, end a life in an instant. The more we send up, the more crowded the sky becomes. We track thousands of objects, watch for close calls, perform maneuvers to dodge the fastest threats. Yet, sometimes, a piece is missed, and a spacecraft returns home with scars, pits, craters, dents that speak of near disaster. Leaks, too, haunt the mind of every astronaut. The air inside a spacecraft is precious, finite, delicately balanced. A single hole, the width of a pin, can drain the life from a capsule in hours. There are drills, there are protocols, there are patches ready in every station, every ship. Astronauts are trained to listen, to smell, to notice even the faintest hiss, a sound that means everything. In microgravity, air doesn't settle, doesn't pool. It vanishes in all directions. The search for a leak is a race against time, a silent battle to save the only breath you have. And the danger of fire. Fire on Earth rises. It can be outrun, contained, fought with water, with foam, with sand. In a spaceship, there is nowhere to run, nowhere to hide. Fire floats, spheres of flame forming in slow, beautiful terror. Smoke lingers. There is no wind, no gravity to carry it away. The risk of suffocation, of toxic fumes, is as real as the heat itself. That's why every system is checked, every cable, every plug, every switch, designed to avoid sparks, to avoid disaster. Every crew member trains for this, donning masks, grabbing extinguishers, sealing off compartments in seconds. It's not just survival, it's choreography, rehearsed and rehearsed again. And then the isolation. The farther you go from Earth, the smaller the window home becomes. Days and nights blur, messages take longer to arrive. The voices of friends and family grow faint, distant, as if calling across a canyon. The mind, in its solitude, can become restless, anxious, even haunted by doubts and fears. Astronauts speak of longing, of loneliness, of the need to invent new routines, games, music, letters, private rituals to hold on to a sense of self. And, well, the bonds with crewmates become everything, a family of circumstance, forged in the crucible of confinement. But it's not just the mind that's tested. The body, too, suffers from confinement, from the absence of gravity. Muscles weaken, bones thin, fluids rise to the head, sleep becomes elusive. The immune system, that ancient defender, weakens, cuts, heal slower. The body is, in some ways, undone by the place it inhabits. And the psychological stress of knowing that should something go wrong, help is far away, sometimes impossible to reach. Well, that's a weight that never truly lifts. That's why every mission, every ship, every station is built with layers of redundancy, with escape plans, with safe havens. There are drills for fire, drills for leaks, drills for medical emergencies, drills for, well, the unimaginable. To fly in space is to live in a constant state of preparedness, to balance wonder with caution, to dream with eyes wide open. And history has its scars. There have been accidents, some small, some tragic, lives lost, missions ended, lessons written in the language of failure and grief. Each disaster, has led to new rules, new safeguards, new ways of thinking. We remember the names Challenger, Columbia, Soyuz, Apollo. We honor them by learning, by changing, by refusing to repeat the same mistakes. And it's not only the journey outward that's risky. The return to Earth is its own trial. Re-entry, plunging through the atmosphere at hypersonic speeds, turns the skin of a spacecraft into fire. Heat shields must hold. Angles must be perfect. Too shallow, you bounce off the air, lost in orbit. Too steep, and you burn. Every safe landing is a testament to preparation, to engineering, to a margin of error measured in seconds and centimeters. And there's one more danger, subtle but insidious, the long-term effects of living away from the world you were born to. Months, years in space can reshape a person physically, emotionally, spiritually. Eyesight may change, bones may never fully recover, some return with new allergies, new sensitivities. Some find the Earth itself strange, heavy, too bright, too loud. The price of exploration is written not just in risks taken, but in changes accepted. So space is not a place of comfort, not a paradise, but a frontier alive with risk, rich with possibility, and never free of danger. And yet, despite everything, we keep going, we keep dreaming, because, for every risk, there is a reward, knowledge, perspective, connection, wonder. We grow older, clocks tick, and the universe waits full of shadows, yes, but also full of light. And as we look to the future, as we ask what comes next, we realize that every danger, every setback has forced us to become better, to invent, to adapt, to rethink what is possible. In the next part of our journey, let's look at the other side of that coin, how facing the challenges of space has changed life on Earth itself, how the technologies, the lessons, the creativity born of risk have come home, shaping our world in ways we often take for granted. So, when we talk about space exploration, it's easy to imagine the images, rockets, blazing upward, astronauts floating, rovers crawling across distant worlds. But what's less obvious, what's maybe even more profound, is the way these journeys have changed our lives here on Earth. Because every risk, every invention, every challenge overcome out there, in the vacuum, has a ripple, a consequence that reaches back home. That's the hidden legacy of space travel, the gifts it brings us, often in ways we don't expect. Let's start with the materials. Space is, well, a harsh teacher. Every gram counts. Every structure must be as light as possible, but also strong enough to survive the violence of launch and the silence of orbit. Engineers have invented new materials, composites, alloys, fabrics woven from carbon or Kevlar, ceramics that shrug off heat and cold. These are not just science fiction, they're woven into the world all around us now. The bicycles we ride, the cars we drive, the planes we fly, all have borrowed from the ingenuity first, sparked by the needs of space. And, well, think about water. On a space station, water is more precious than gold. It has to be recycled, purified, used again and again. The technology that makes this possible, filters, membranes, advanced chemical processes, was born out of necessity above the clouds. But now, it saves lives here below. Disaster zones, remote villages, war-torn cities where clean water is hard to find. These systems turn the undrinkable into hope. Every sip is a small echo of the innovation that keeps astronauts alive. Cameras, let's pause on that. The need to see farther, sharper, more clearly led to cameras and sensors that now live in our pockets. The high sensitivity sensors, the image stabilizing technology, the miniaturization, these were first designed for spacecraft, for telescopes staring deep into the cosmos. Now, they let us capture our world in detail our ancestors could not have imagined. Every photo snapped on a phone carries a little piece of that cosmic curiosity. And, robots. Operating a rover millions of kilometers away in an alien landscape requires precision, adaptability, and creativity. The algorithms developed to drive a Mars rover, the sensors that help a robot land on an asteroid, have shaped the robots that assist in our factories, our hospitals, even our homes. Telemedicine, remote surgery, bomb disposal, these miracles of control and feedback trace their lineage to the distant worlds where only machines can go first. It's not just hardware. The way we pack food for long journeys, how we preserve it, keep it fresh, safe, compact, has changed the way we eat on Earth. Packaging, preservation, freeze-drying, nutritional engineering, all refined for space, all finding their way onto grocery shelves and kitchen tables. That pouch of dried fruit, that energy bar, that meal ready in moments is, in some way, a child of the stars. And navigation, that invisible web, the global positioning system, GPS guides our every move, from planes in the sky to cars on the road, even to joggers finding their way through a city at night. GPS is a constellation of satellites, each one a clock, a point of certainty, circling far above. The precision, the timing, the calculation of positions to within meters, all this was born from the mathematics of orbits, the dreams of explorers who needed to know exactly where and when they were. Thermal insulation, the blankets that keep spacecraft from freezing or frying, the foams that protect astronauts from the chill of space, these have found a second life on Earth. Homes, offices, even coffee cups now use these same materials to keep warmth in or heat out. That shimmering emergency blanket in a first aid kit, it was tested first in the vacuum, in the silence, in the necessity of keeping a human body alive where nothing wants to help. And medical science has changed too. Space is an unnatural place for a human body. Bones weaken, fluids shift, the immune system falters. The study of these effects of bone loss, of muscle atrophy, of aging at an accelerated pace has deepened our understanding of osteoporosis, of muscle diseases, of how to keep our bodies strong. Medicines developed for astronauts, methods of monitoring health remotely, have helped countless patients here below. So it's not just about bringing back rocks or taking pictures. It's about, bringing back new ways of living. The lessons of scarcity, of resilience, of recycling and reusing, these are lessons that our crowded, warming planet needs more than ever. Every drop of water cleaned, every bit of energy saved, every gram of food preserved carries the spirit of a world where nothing can be wasted. Even the way we think about emergencies, about backup systems, about redundancy, about planning for the worst, has been shaped by the challenges of space, disaster, preparedness, safety protocols. The way we respond to the unexpected all owe something to the men and women who learned above the sky that survival is an art of preparation and humility. And as space becomes more accessible, as private companies build rockets, as ordinary people begin to dream of visiting orbit or even the moon, the pace of innovation accelerates. The drive to do more with less, to solve impossible problems spills over into every field: energy, transport, computing, architecture. The world of 2025 is more connected, more inventive, more restless because of the momentum born out there beyond the blue. So, when we look at a child using a tablet, at a patient given a second chance by a robotic surgeon, at a rescue worker warming herself in a silver blanket, we are seeing the echoes of rocket fire, of starshine, of human ingenuity stretched to its limit. And as we reflect on what we have learned, on what has come, home from the stars, a new question arises. Who gets to go next? Not just astronauts, not just scientists, but all of us. Is space, once the domain of nations, now open to the bold, the curious, the dreamers with a ticket and a vision? Because, and, well, the future of space travel is not just about invention, but about inclusion, about turning exploration into experience, adventure into opportunity. So, as we set our sights on this new age of private rockets, of orbital hotels, of journeys for the many, not the few, let's consider what it means to leave home, not just as a hero, but as a traveller, a tourist, a citizen of a world growing larger every day. So, when we look around at the world in 2025, we realise, well, something subtle but astonishing has happened. Space is no longer just the realm of governments or heroes chosen for their bravery and brilliance. The lines are shifting. The world of rockets and orbits, of countdowns and distant laboratories is opening up to new players, new possibilities, new dreams. The era of private space travel and space tourism has arrived not just as a headline or a promise, but as an unfolding reality. You see, space tourism was, for decades, little more than a fantasy, a thread of science fiction, a dream for the future, a scene glimpsed in movies or read about in stories. But in the last few years, that dream has started to take shape. Private citizens have already bought tickets, boarded rockets, and glimpsed the edge of space for themselves. And that's something, isn't it? That shift from state-sponsored missions to private adventure has changed the whole rhythm of exploration. And these first journeys, well, many are what we call suborbital flights. The rocket rises, bursts through the boundary of space, the famous Kármán line, 100 kilometers up, then arcs back, letting its passengers float, weightless, for a few minutes before gravity tugs them home. For those few minutes, everything you know is changed. There's no up, no down, only the thrill of drifting, of watching the earth curve beneath you, of seeing the blackness above. That is the new edge of human experience, something that even a decade ago belonged only to astronauts. But for those who crave more, there's the possibility, still rare, still reserved for the wealthy or the bold, of orbital tourism. Here, the stakes are higher, the training longer. Ordinary citizens, teachers, artists, entrepreneurs can now, if chosen or if funded, spend months preparing, learning to cope with the risks, the routines, the realities of living in orbit. They learn how to move, how to eat, how to respond in emergencies. Their journeys may last days, sometimes longer. They return changed in their bodies, their minds, their view of Earth. The price? Well, for now, it's high. A ticket to orbit, or to a few minutes of microgravity, costs more than most of us could ever dream of spending millions for a seat, fortunes for a week. But, and as private companies innovate, as rockets become reusable, as the industry grows, that cost is slowly coming down. The rocket you ride today may fly again tomorrow, carrying new passengers, new hopes. Reusability has become the new mantra, the new promise, a way to make the sky just a little more open. And some companies dream even bigger. They imagine orbital hotel spaces designed not for science, but for comfort, for wonder, for ordinary people to sleep, to look out the window, to dine together while circling the Earth. These hotels, these stations, are still under construction, still mostly blueprints and test modules, but, and, well, they are coming. Perhaps in another decade, you'll see advertisements for a room with the best view imaginable, a bed, a porthole, and the entire spinning world beneath. The pace of change is quickening. Private enterprise has always been restless, always eager to move faster, to take risks, to leap where bureaucracy might hesitate. We've seen new rockets tested, launched, landed, and launched again, sometimes in the same week. And this has changed everything, not just the cost, but the speed, the flexibility, the spirit of exploration itself. Space is becoming an industry, not just a program. Not just a symbol, but a marketplace, a stage for competition and cooperation, for bold ideas and commercial dreams. It's not just about fun. The rise of private companies has created an ecosystem where technologies evolve quickly, where mistakes are learned from, where success is measured in rapid cycles of test and failure and flight. The rockets themselves are smarter, guided by computers that can land them upright, catch them as they fall, prepare them to fly again. And the partnership between private companies and national agencies means that the benefits flow both ways. What is learned in a test flight or a tourist mission is used to send satellites, to repair space stations, to dream bigger dreams. And, well, that's the story. Not just a transition from government to private, but a merging. We now see astronauts sharing rides with artists and teachers, researchers working alongside tourists. Space is slowly becoming not just a destination for the select few, but an experience to be shared. Each new traveller brings back a new perspective, a story, a photograph, a sense of awe. That sense of awe, that overview effect, is no longer the exclusive domain of the highly trained or the specially chosen. It is, for a small but growing number, something you can buy a ticket to feel. But there are challenges. The cost is still enormous. The risks are still real. For every dreamer who floats above the world, there are teams of engineers, doctors, trainers, support staff, working tirelessly to make sure the journey is safe. The industry is young. The rules are still being written. Who is responsible when things go wrong? Who owns the orbit, the station, the window on the world? These are questions for the next era, questions that mix law, ethics, ambition, and, well, the very meaning of adventure. And as the industry matures, the ripple effects grow. New jobs are created, new technologies developed, new stories told. What begins as luxury for the wealthy may, with time, become something more. Just as air travel was once for the few, but now is woven into the fabric of everyday life. We stand at the threshold. The age of space travel for all is not here yet, but it is coming closer, one launch at a time. So, and as we let our minds drift toward that future, toward holidays in orbit, toward honeymoons beneath the auroras of space, toward classrooms floating above the world, we might ask, Who will be the guides, the pioneers, the storytellers for this new world? Who are the people who led us here? Because the story of space travel is not just about rockets or money or invention. It is, in the end, about people, about the dreamers, the risk takers, the ones who dared to step into the unknown. Let's look closer at the faces behind the facts, the milestones, and the moments, and see what it really means to change the course of history, one person, one mission, one dream at a time. So, as we turn the page to this next chapter, we find ourselves, well, face to face with the real heart of the story, the people and the moments that shaped everything. Space is not just a theatre of technology or a showcase for invention, it's a deeply human journey. Every leap, every first, every turning point is carried on the shoulders of individuals who dared to step out into the unknown, and sometimes on the efforts of thousands whose names we may never know. You see, the very first person to leave the planet, to cross that invisible border into space, did so not in comfort, but in a cramped capsule atop a tower of fire. Yuri Gagarin, just a young pilot, chosen from many, trusted with a mission that no one could fully predict. He was launched not as a passenger, but as a pioneer, a test pilot at the very edge of possibility. That first orbit, that 90-minute loop around the world, was a moment that echoed everywhere, an entire species suddenly aware that it could leave its cradle. And then there was, well, the first person to walk on another world. Neil Armstrong, taking that giant leap, became a symbol for something much bigger than himself. That grainy broadcast, watched by millions, is a reminder that sometimes history arrives softly with a whisper and a dusty footprint. It's not just the step, but the silence afterward, the sense that for a moment everyone looked up and wondered what it meant to be human. But it's not only about those who set records or plant flags. The first artificial satellite, Sputnik, was a sphere of metal and wires, no bigger than a beach ball. Yet, when it beeped from orbit, it changed everything. The age of communication, of observation, of seeing the Earth as a whole, began not with a shout, but with a simple, steady signal. The world was suddenly smaller, more connected, a place where weather, war, and wonder could be tracked from above. The early space stations, too, are milestones not just of engineering, but of endurance. To live for weeks, then months, then years above the sky, this was a test of both body and spirit. Mir, Skylab, Salyut, and then the ISS. Each was a home, a lab, a proving ground. They showed us that it's not just possible to visit space, but to live there, to adapt, to belong. Every day spent circling the Earth was a lesson in resilience, in the art of making do, in the quiet courage of the everyday. And none of these missions would have happened without those who dreamed them up in the first place. Long before rockets flew, there were thinkers, Tsiolkovsky, Goddard, Oberth, who drew equations on paper, who imagined paths and orbits before the technology even existed. They calculated, theorized, argued, and waited. Their patience, their willingness to be told they were wrong, is woven into every mission, every launch, every small victory. Many of the first astronauts, cosmonauts, and taikonauts were test pilots. They were used to danger, used to risk, used to trusting their lives to machines. But it's not just their daring, it's the way they accepted uncertainty, the way they trained again and again for situations no one could predict. Every time they strapped into a capsule, they carried not just science, but faith in their teams, in their own training, in the possibility of coming home. And then there were the repairs, the rescues, the times when things went wrong. There have been moments in space history, some public, some secret, when human skill, ingenuity, and sheer stubbornness made the difference between success and disaster. Astronauts who fixed satellites in orbit, who brought crippled ships home, who faced fire or vacuum or malfunction, and found a way. These were not just test pilots, but mechanics, doctors, engineers, and sometimes poets, people ready to solve problems no one had ever seen before. And, well, there are moments that remind us space is not just for one nation, or one group, or one language. The International Space Station is perhaps the best example, a place where former rivals became partners, where flags from many nations hang together, where meals are shared and experiments are done in the name of everyone, the handshake in orbit, the first joint missions, the long nights of negotiation and compromise. These are as important as any launch or landing. They show us that cooperation can be as bold as competition. So behind every major milestone, there are countless names, countless hands and minds. The engineers who designed the impossible, the scientists who made the case, the families who waited at home, the doctors and trainers and planners who made survival routine. It's not just one hero, it's a tapestry woven from thousands of threads. There is a cost. Some names are written in memory because they did not come home. The risks are real, the failures are public. Every accident, every lost mission, every hard lesson is a reminder that exploration is never safe, never easy. Yet we go on because the story is bigger than any one of us. Each new milestone stands on the shoulders of the last, and every mistake is turned with time into knowledge. And the story is always growing. Today, in 2025, astronauts are as likely to be scientists, engineers, teachers, doctors, artists. The field is widening. The firsts are still coming. First woman on the moon, first commercial pilot in orbit, first child born in space, perhaps one day. The milestones ahead are not just about flags or footprints, but about inclusion, about diversity, about the idea that anyone can play a part. So, as we stand at this moment in history, we realize it's not just about the past, it's about the future. The children who watch a rocket rise, who build a model, who dream of Mars or beyond, they too are part of the story. The history of space travel is still being written every day by everyone who chooses to look up, to ask a question, to wonder what comes next. And, well, what does come next? If the first chapters of this journey were about leaving home, the next are about building a new one out there, in the darkness, under new suns. The future of space travel is as open as our imagination, as wide as the universe itself. Let's take a final leap into that future together and see what possibilities wait beyond the facts, beyond the milestones, in the yet unwritten story of tomorrow. So here we are standing at the very edge of what is known, looking out into the deep, uncharted future of space travel. And, well, if the story so far has been about crossing boundaries, leaving the Earth, reaching the Moon, building homes in orbit, touching the surface of Mars, then the future is about pushing those boundaries further and further still. It's not just about what we can do today, but what we might dare to do tomorrow. It's not just out there, it's in here, in the ideas, the dreams, the ambitions that keep us restless, always searching. Let's imagine what might come next. Nuclear-powered spacecraft, for instance, are not just theory, they're being planned and built right now as a way to give ships the stamina, to go farther and stay longer. Chemical rockets have taken us to orbit, to the moon, but nuclear engines promise a new kind of journey. These engines could provide a steady, efficient push, cutting months from the travel time to Mars, perhaps making the outer planets accessible in a single human lifetime. The radiation, the engineering challenges, the politics, well, they're not small, but, and the reward might be the entire solar system opening up, bit by bit, to human reach. And there's another vision, solar sails, ships driven not by engines or fuel, but by the pressure of sunlight itself. A giant reflective sail unfurled in the vacuum, pushed ever so gently by photons. It's not fast, at least not at first, but in the endless silence of space, speed builds and builds, with no air, no friction, nothing to slow you down. Over months or years, a solar sail could reach unimaginable velocities, perhaps enough to cross the gulf between the planets, perhaps even to escape the sun's grip entirely. Some thinkers go further, much further, dreaming of generation ships, vast arcs where hundreds or thousands might live and die over centuries, carrying the story of humanity to another star. The distances are vast. Even the nearest star is more than 4 light years away, 40 trillion kilometers. Light itself, the fastest thing in the universe, takes years to make the journey. So a ship that could cross that space would need to be a world in itself, a place where children are born, grow old, and, well, never know another home but the ship, until one day their descendants arrive. The truth is, space beyond our sun is a wilderness of scale. The distances are so huge that even the most optimistic technologies, the most daring visions, struggle to make them real. Outside the solar system, radiation is harsher, the cold more complete, the darkness absolute. There are no way stations, no rescue, no supply lines. Every mission will need new ideas, autonomous machines, self-repairing habitats, artificial intelligence that can manage ships, analyze dangers, perhaps even make decisions we would make ourselves if we were there. We already see the first steps toward this. Robotic probes are scouting the frontier, teaching us about the radiation, the dust, the emptiness between stars. They are the vanguard, the scouts, the first messengers of Earth to the galaxy. The lessons they bring home about propulsion, about shielding, about endurance are the foundation for everything that will come after. And then there's the idea of becoming a multi-planet species. It's not just a slogan, not just an ambition for a select few visionaries. It's a kind of insurance, a way to hedge against disaster, to spread the risk, to make sure that no single event, no war, no asteroid, no plague can erase everything we have built. Mars is the first candidate, but not the last. Moons, asteroids, artificial habitats, each could become a home, a new chapter in the story of life. And to build in space will require not just rockets, but new tools, 3-dimensional printers, machines that can turn dust or ice or regolith into walls, beams. Even machines themselves will let us use local resources, will let us construct vast habitats, solar farms, greenhouses, laboratories, all without bringing every bolt, every pipe from Earth. It's not just about sending things up, it's about building, growing, inventing in place. Asteroid mining, too, shifts from science fiction toward reality. Out there, in the asteroid belt, are trillions of tons of metal, water, carbon resources that could fuel industry, provide air and water, build cities in the void. Robots may one day dig, crush, refine, ship raw materials where they are needed, making space not a barren desert, but, well, a place of abundance. But for any of this to work, we'll need infrastructure, fuel depots circling Earth or parked on the moon, outposts to refuel, to repair, to rest. It's a network, a web that makes travel beyond home possible, not just for a few, but for many. And, well, artificial intelligence will be the backbone of this future. Human crews will be rare, precious, vulnerable. Machines will have to watch, to act, to anticipate, to keep the systems running through years or decades of solitude. That's the thing. The more we push out, the more we must trust machines, must design for the unknown. It's not just the rockets that will change, but our relationship to risk, to distance, to time. The first interstellar missions may not even be crewed. There may be AIs carrying our thoughts, our questions, our culture, and maybe returning with answers we cannot even imagine. And in the end, the future of space travel is not written only by science or engineering, but by the choices we make today, by the balance of curiosity and caution, by what we value, by what we dare to attempt. There are ethical choices: who gets to go, who decides how we treat the worlds we visit, what responsibilities we carry with us. There are economic choices: what to invest in, who benefits, how we balance the dreams of the few with the needs of the many. Every new technology, every new leap will raise new questions. Should we send humans to other planets if the risk is enormous? Should we build machines that can think for themselves? Should we change other worlds or protect them as they are? Should we use space to solve Earth's problems, or will we only bring our problems with us? So in 2025, the future of space travel is a conversation as much as it is an engineering challenge. It's not just the scientists or the governments anymore. It's private companies, artists, ethicists, school children, everyone with a voice, everyone with a stake in what comes next. And, well, every decision made now, every mission, every invention, every agreement will shape the centuries to come. Our future in space is, in a very real sense, a mirror of who we are and who we hope to become. Not just out there, but in here, in the choices and the dreams we share. As we close this journey through 100 facts and 12 chapters, maybe we're left not with certainty, but with wonder, with the sense that the story isn't over, that the facts are only the beginning, that each fact is a small spark in a larger fire. The next questions, the ones about life on space stations, about cities on Mars, about the destiny of a species that won't be content to stay home, those are waiting just beyond the next horizon. Let's pause here, catch our breath, and see where curiosity will lead us next. So here we are at the end of one journey, and well, perhaps at the beginning of another. And isn't that always the way with science? Every answer unfolds into more questions. Every horizon that we reach only reveals another, a little farther out, a little more faint. We started with a simple idea to count 100 facts about space travel. But what we've found, what we always find when we follow curiosity, is that the facts themselves are only markers. They're like stones in a river, stepping points across a flow that never quite stands still. We've drifted from the first trembling launches, where hope and terror were almost the same thing, to the calm confidence of living for months at a time above the sky. We've watched as rockets grew reusable, as stations grew into homes, as journeys once reserved for legends have become open at least a little bit to all of us. And um, we've seen how every step outward changes the world below. That that's something I keep coming back to again and again. The way each discovery, each invention, each bold risk in space echoes back to Earth, changing our days in ways we barely notice. But, and perhaps the greatest change is inside us. Because space is not, finally, about escape. It's not about running away from our problems or hiding in the silence. It's about looking back. It's about seeing ourselves small, blue, fragile, improbable, set against the endless dark, and feeling, just for a moment, a sense of kinship with everyone else down here. We grow older, clocks tick, but the questions remain. Who are we, really? What do we hope for when we look up? What do we fear? What kind of future are we, all together, building? It's not just out there, it's in here. You see, in the way we dream, in the way we work, in the way we tell stories about ourselves. To travel in space is to test our limits, but also to reveal our hopes, our anxieties, our willingness to be surprised. The universe is vast, yes, and cold, and sometimes frightening, but it is also impossibly beautiful. It's a canvas painted with stars, with mysteries, with stories waiting to be told. So, well, as we wrap up this journey through 100 facts, maybe what stands out isn't the numbers or the records or even the Carsi risks, but the sense of wonder that underpins it all. Every astronaut, every scientist, every engineer, and every child looking up at the sky shares that same sense of awe. The feeling that we are part of something enormous, something old, something still unfolding. And isn't that what matters most? That we keep asking, keep searching, keep risking a little comfort for a taste of the unknown. It's not just about learning facts. It's about changing the way we see, changing the way we think about our place in things. Every story from space, every photograph, every broadcast is a kind of invitation. Come see, come wonder, come be changed. The universe, you see, doesn't ask much of us. It simply offers itself. The light from distant stars, the faint glow of galaxies, the cosmic background that whispers of beginnings. These things arrive at Earth across billions of years and wait for a mind to notice, for a heart to care, for a spirit to wonder what it all means. Maybe that's the greatest fact of all. Not that we travel, but that we wonder. Not that we reach the edge, but that we long to cross it again and again. The story of space is, finally, the story of curiosity, of the hunger to know, to understand, to become, little by little, more than what we were yesterday. So, and as you drift towards sleep, or let your mind wander wherever it will, remember that you're part of this too. You're part of the grand experiment, the endless journey, the dance of minds and worlds and questions that will never quite be finished. The facts, the milestones, the heroes, yes, they matter. But it's the questions and the longing and the quiet moments of awe that linger. And, well, if you ever doubt the value of wonder, look up. Find a star or a planet or just the deep blue of the sky at dusk. Remember that someone, somewhere, is building a ship, plotting a course, daring to dream just a little bit bigger. And in 2025, as we share this world fragile, beautiful, spinning through the dark, maybe what we need most is just to keep looking, keep listening, keep sharing the wonder with each other, because, and well, the next chapter is always unwritten. The next question is always waiting. The universe is not finished. We are not finished. So let's promise ourselves quietly to keep going, to keep reaching, to keep wondering, no matter where the journey takes us. And if you've enjoyed this exploration, if you felt a little awe, a little hope, maybe even a little sleepier than when you started, remember that you can always return. There are more stories to tell, more questions to ask, more horizons to chase. Thank you for joining me in this gentle journey among the stars. So, well, until next time, good night, and may your dreams be full of light.